Hello students, in this video we are going to see the topic under for the module 5, which is linear algebra. The topic is test of consistency. The previous two video we have seen for the topic of under the linear algebra, row element transformation and the echelon form, and using the echelon form how we can able to find a rank of a matrix. So in this video we are going to see the test of consistency. That is nothing but conditions for consistency and the types of solutions. So first we are going to consider a system of m equation in n unknowns, so which is represented in the matrix. So you can take it as an equation. So the general format has been taken in that. I can take it A matrix. What is that? The coefficient of all the x1, x2, x3 up to xn. We can make it as in the, what is that? In terms of matrix format. So A11, A12, A up to A1n. Similar for second row and the third row up to, what is that? Mth row till n column. That's what AM1, AM2, etc. AMN. Okay. So now can take it for capital X. So what is it? Capital X is nothing but it is there in the unknown. What is that? X1, X2, etc. Xn. So total n unknowns will be there, and B is nothing but B1, B2, etc. Bn. So A is called the coefficient of matrix. So one equations I'll show you. If you have A11, you have an equation as X1 plus A12. So you have equation as X2 plus etc. up to you have it A1n into Xn, which is equal to B1. This is for first row. So similar all the rows you can make it and you can write it in AXB. Okay. So A is called the coefficient of matrix. So now together of A and B we used to call it as an augmented matrix. Okay. So now the system of equations represented by the matrix of equations Ax is equal to B is consistent. So when we can tell as a consistent if the rank of A. So row of A, since we have seen in the last video, we know what is that? It is a rank of A which is equal to the augmented matrix. What you will do, no? Using that, reducing the matrix by using the row element transformation to the echelon form. You have to convert to the echelon form. Then you can find a rank. The rank of AB, augmented matrix, should be equal, right? Suppose row of A is equal to row of AB, which is equal to R. Then the conditions for two types of solutions are as follows. Okay. So if it is equal to R means we'll have a two type of solutions are as follows. One is unique solution. So what is that unique solutions? If row of A equal to row of AB, which is equal to R, which is equal to N. So N is having a number of unknowns. Okay. If you have it 3 unknowns, if it is equal to the rank also is 3, right? So R also we can take it for rank which is having what is that? Row of A and row of AB is R. So that is equal to the number of unknowns means you have a unique solutions. Suppose if you have a less than, the unknown value is less than, if you have R is less than of N, then it will have a infinite solutions. So in this cases, n minus r unknowns we can take arbitrary values. Okay. Suppose both the conditions not satisfied. That means row of A is not equal to row of AB. That means both the rank is not equal. Implies that the system is inconsistent. Okay. So whenever it is equal only, you can able to find a solution and you can tell it is a consistent. If it is a not equal, it will be inconsistent. Does not possess solutions. Okay. So only these three types is there for the system of equations. Now we'll go to the problem. So the first question, test for consistency and solve. The question is asked to check the consistency and they have to find a solution of the equations. So you have 3 equations with 3 unknowns. What is that equation? X plus y plus z is equal to 6. X minus y plus 2z equal to 5. 3x plus 4y plus z is equal to 8. Isn't it? So what is your unknowns here? X, y, z is there. Like a variable is an unknown, right? So what we need to find out? The solution is nothing but you need to find the value of your x, y, z. Instead of normal solving method, here we are going to choose in matrix format. Okay. So first we have to test the consistency whether the solutions will occur or not. Then we can go ahead whether it is a infinitely many solutions or unique solutions, right? For that, first what we need to verify the rank of A must be equal of rank of augmented matrix. So first take it the augmented matrix of A, B. What is that? The coefficient of the first row, you can see 1, 1, 1 and 6. It is a B matrix, right? And 1 minus 1, then coefficient of his result is 2 and at the right side will be a 5. And the third equation, x coefficient, y coefficient, z coefficient, then 8. 3, 1, 1, 8. So it is called as an augmented matrix. Now what you can do? You can try to make it as an echelon form since we need to find it a rank. Okay. So what is that? So first one, as it is that using the first row, I need to make it 0 for this position and here, right? So to make this 1 will be 0, I need a minus 1. Just you can subtract it. R2 minus R1, you can get it, right? That is what 0 minus 2, 1 minus 1. It's coming for your third one, I have a 3. To make it 0, I need a minus 3. So what I'm going to do that, multiple 3 in R1, subtract with your R3. You can get R3 implies R3 minus 3, R1. So I'll get 0, minus 2, minus 2, minus 10. Now, what is that? The equivalent matrix of AB is 1, 1, 1, 1, 6. Then 0, minus 2, 1, minus 1. Next step, I need to make this minus 2 to 0 because then only I can able to get it to find your rank, isn't it? So what is that? So here, if you have it 0, here I have a minus 2, here also minus 2, just you subtract it. R2, R3 minus R2, you can get 0, 0 and minus 2 minus 1 will be minus 3, minus 9, minus 1, minus 10 plus 1 will be minus 9. Okay. Now, in this test the consistency and the solving part, no need to make it that entry must be 1, all those things. Okay. Directly once you make it these 3 places 0, then you can go to verify whether the solution will exist or not, right? You can able to find a solution or not. For that, first only the rank of A. What is that? This will be A part and this is together of A and B, isn't it? So this 3 cross 3 matrix will be A. What is the rank? Number of non-zero rows. What is that? It is a non-zero row. So rank of A is 3, right? Next, together of A and B, what I got it? It is 3. So the both is equal. At the same time, the rank, what is that? It is R is equal to 3. That is nothing but number of unknowns. The system, what is it? Will go a first case, right? The given system of equation is consistent and will have a unique solution. Now find a solution. How we will find? Again, you can do the substitution. X plus y plus z is equal to 0. Minus 0 will be x system is 0. So minus 2y plus z equal to, right side I have a minus 1, isn't it? Next one, minus 3 z equal to minus 9. That implies z is equal to 3. Then substitute z is equal to 3 in the equation number 2. What will happen? 3 minus 2y plus 3 equal to minus 1. 3 you can take that side. It will be a minus 4, isn't it? So minus 2 and by minus 4 by minus 2 it will become a 2. Y value is 2. Substitute z and y value to the first equation. You can get your x value. That's all. Okay. So we'll go for the next question. Test for consistency and solve. So similar, you have a 3 equations and we are going to test the consistency first. So find it first augmented matrix and convert to the 0. So augmented matrix, you can write it A and B. Then converting 0, 4 and 3 is there. And you can convert, what is it? R2 implies R2 minus 4R1. Again R3 implies R3 minus 3R1. You can get it 0 minus 3 minus 5 minus 21. And 0 minus 3 minus 5 minus 21. So looking that easily you can check that both is having a same. So second row and third row just you can subtract it. Entire row will go 0. Here you can check the rank. Rank is 2 only with A matrix, 3 cross 3 matrix. 2 non-zero rows there. So rank is 2. Then together of A and B, augmented matrix rank is 2, right? here the number of unknown is 3, which is having a R is having a 2. So 2 is less than of 3. So which case it will come for second case. That means you will be having many solutions, right? Infinite many solutions. You have to introduce a arbitrary constant. So you can see that is what is mentioned. So n minus r, which is equal to 1, and have a one variable can take. You can consider one variable, right? So now you can substitute what is that, x plus 2y plus 3z equal to 14, then minus 3y minus 5. So minus you can multiply it, you will get 3y plus 5z is equal to 21. What I am going to do that, I am going to introduce z is equal to k via arbitrary. Okay, because we need to find a solution in terms of arbitrary, because depends with the k value, we will get many value. That's what the solution says, the infinite many solutions you will get when r is less than n cases. Got it? Now, what is that? Substitute z to the second equation. So, what I'll get? Minus 3y minus 5y, which is equal to minus 21. R. Y is equal to 7 minus 5 by 5k by 3. Okay. So, now you can go with the substitution in equation number 1 for your y value and z value. So, substitute x plus 2 of 7 minus 5k by 3 plus 3k is equal to 14. What is that? To simplify, you can simplify this and take a LCM. You will get x value, which is k by 3. Okay. So, x is equal to k by 3. Y is equal to 7 minus 5k by 3. Then z is equal to k. So, which is represent infinite many solutions, since what is that? K is arbitrary. Right. So, when you have it less than cases, r is less than of n cases, we will be getting infinite solutions. Okay. So, one more example. Show that the following system of equation does not possess any solution. What is that meaning? The question itself has been, you have to show that the system of equation does not possess any solution, means it should be inconsistent. Inconsistent means what is the condition should satisfy? Your rank of A should not be equal to rank of AB, isn't it? So what you have to do? First you can write your augmented matrix, then find a rank, then you can compare your rank of A whether it is not equal to rank of A and B, right? Augmented matrix. So we'll go with, take it AB. So write all the coefficient and the augmented matrix, then which will be equivalent to, make it 0 for 3 and 7. What you have to do? R2 implies multiple 3 in R1, 5 in R2, because we don't have any common factor here. So minus 3 R1 plus 5 R2. Then similar, you can simplify, you will get 0, 121 minus 11 and 30. The next one you have R3 implies minus 7 into R1 and then 5 into R3. Then you will get new R3, isn't it? So 0, minus 11, 1 and minus 10. So now you can go with the next one. I make to 0 here. So what is it? 121 and 11 you have a common. Just to multiple with 11, then you can add it. That was as written, R3 implies R2 plus 11 into R3. You will get 0, 0, 0 and minus 80. Now what is that? The rank of only with the A terms, right? So this will be only A part. Okay. So this matrix, the rank of this matrix is what is that? I have only with 2 non-zero row. That's why rank of A is 2, right? Similar, you can see this together of A and B, minus 80 has appeared. So the rank of AB is 3, right? So it is clearly view that the rank of A is not equal to rank of AB. The system is inconsistent. Okay. So that's all for the test of consistency. Thank you.